All right, folks, I think we are good to go. Let's start with just a bit of housekeeping. So my name is Tally. I head product marketing over at Nucleus, and with me is Aaron Unterberger, who's the director of solution engineering. And we will be talking about achieving continuous exposure management in cloud native environments following Nucleus's latest product update and launch. So before we begin, I just wanted to let you know that you can drop your questions at any time during the webinar, and we will answer them as we go along. In addition, this is one of our monthly webinar series. So at the end of this webinar, we'll be sharing with you the topic of next month's webinar, and we'll hope you join us there as well. So with that, Aaron, take it away.
All right, thanks, Tally. All right, hello and welcome, everybody. So as Tally had mentioned, we're going to be covering how to achieve continuous exposure management in cloud native environments, and specifically talking about one of our new capabilities called container workloads, but that falls in a larger family of how do we best secure elastic environments. So for today's session, we're going to first cover what the problem is, what we're seeing, and why traditional vulnerability management fails when adapted to cloud. We'll introduce the Nucleus Cloud Native Vulnerability Exposure Management capabilities with adaptive context. So that's the container workloads. And then talk about some of the key capabilities, benefits, and use cases. We'll leave some time as well for Q&A, but also feel free to ask questions throughout and just post them in the chat. We'll keep an eye on them and look forward to any questions or engagement that you all have. So as we all know, organizations have been moving to the cloud for some time, and when looking at security and vulnerability management approaches, we're seeing that just adapting an on-prem vulnerability management model to cloud doesn't really support the dynamic nature of the cloud. So some of the great things that the cloud brings, with the ability to rapidly scale, to rapidly innovate, and democratize access to compute for different teams, that brings about challenges with how we secure our assets. One, assets can be highly ephemeral. So there could be assets that we spin up for periods of high demand, and there can be asset lineage that's difficult to track because those ephemeral assets kind of are maintained in layers. Also, with the modern architecture and infrastructure that cloud brings, it also enables rapid and continuous delivery for new software, new versions, and evolution of your compute. And then it also enables, through that automation, the ability to have complex layered environments like a microservices environment. So things are highly complex, they're highly dynamic. Things like ownership and lineage and risk are difficult to understand with such a complex environment. So what's happening? So imagine that we have a running container, and that running container is spun up, and maybe we see that there's a vulnerability on that container, and then that container maybe is spun down. And so we lose the context of that container as it's spun down in runtime. Additionally, that maybe the container is using an image, and a new image is generated for the next release. That image version essentially wipes the state of that container and that vulnerability, essentially for many scanners identifying this as a new vulnerability, even though it's maybe a vulnerability that persisted from a previous version. So ultimately what's happening is the ephemerality makes it very difficult to understand when truly a vulnerability first appeared and how best to prioritize things getting fixed and understanding what isn't getting fixed and is still out there.
I think, Aaron, if I may just interject for a second, I think at the core of this problem is it's almost like a fundamental question, but when you have a finding on an ephemeral asset and that asset goes away for whatever reason, what happens to the risk? And at the core of that question is, well, assets are ephemeral or can be ephemeral. The risk is not. And then the question is, so how do you manage risk on assets that are going away? How do you make the risk not ephemeral in a meaningful way? I think is almost like a philosophical question, but that's the one that is the core here.
Yeah, that's very much the question that we're looking to answer, and that a lot of our customers have also struggled with and are looking to answer. And so why does traditional vulnerability management fail in the cloud? So you can really chalk it up to there's scattered visibility. That also severs risk context. There's a lot of complexity when we think about the runtime, and that also makes ownership and attribution unclear. So with scattered visibility, often the different layers of containers are usually viewed as different parts of the application or different parts of the scan tooling. So maybe I'm running container and registry scans on the images themselves. I might be doing runtime scanning and CSPM scanning for the runtimes. And then there could also be different layers of ownership where maybe there's a separate team that manages our base images versus what image the application is using that's built off of a base image. And then different applications may be using the same common image, but having different teams that support each application. This creates a disjointed picture, and so understanding risk and context, for example, one of those applications might be a mission critical application. And so how does that inform us on the risk and urgency of remediating a vulnerability that we found on a container? And also the ephemerality and changing nature of the runtime, right? So things are constantly changing. And so how do we have a more static understanding of how things move in and out of deployment and decommissioning or terminating? And finally, if we identify a vulnerability, ultimately, who is responsible for remediating a vulnerability? So an example would be if I have a vulnerability that is found within a container image, I might route that vulnerability to the remediation team, but what if that vulnerability is actually part of the base image? So we're actually playing this game of whack-a-mole of identifying vulnerabilities one step down from where they actually appear in the lineage. And so every image that is built off of that base image is going to have this common vulnerability. All right. So now this is where we introduce the Nucleus Cloud Native Vulnerability and Exposure Management Solutions. So we've invested very heavily within the cloud, and as we all have seen in the security landscape, this is a rapidly growing field. I'm sure we've kept an eye on news with all of the exciting players that are out there, all of the exciting acquisitions that are happening. There's a lot of change and innovation in this space. And so with that, that's brought in a lot of different scanners, scan types, and assets that are being managed. So we've actually introduced over 135 new cloud asset types to support the different inventory types, resources, and services that cloud brings, but also can be assessed for vulnerabilities. We've brought on a number of new connectors for CSPM, CNAP, and cloud workload protections or container workload protection. And then really the focus for today's session we're starting to build out adaptive contexts that can take a rapidly changing environment that's built where services are often layered in and providing adaptive context where you can track and map the cloud native assets to their root causes, to their risk context, and across the continuum of those layers in its lifecycle, tracking the remediation of findings, vulnerabilities, and alerts. So when we talk about adaptive contexts, what we're essentially doing is scans offer a point-in-time view into some asset. It could be the container image, it could be the running container, it could be a front-end underlying VM, it could be assessments. All of these are providing different point-in-time views on the various assets that constitute a container. So when looking at this picture, if you can stitch together the different point-in-time data points across oftentimes different scanners, you create a stable, lasting risk context. You do this by dynamically grouping and associating the different assets across the lineage in terms of the image lineage and then also the deployment locations. You automatically correlate and deduplicate alerts based on ultimately where something is appearing versus reappearing, and then reliably assigning ownership depending on who's responsible for the fix across that complex runtime environment. Having this all in one place essentially allows for the continuous management of risk for a changing environment. Right, so here is actually an example for one challenge that a customer of mine faced was when we're setting SLAs on vulnerabilities, containers present a specific challenge because oftentimes there are container versions that are released, but the vulnerability was actually found in a previous version, or it might have been found in, say, a base version. And so when a new version comes out, it's often resetting the clock on an SLA. So just having continuous delivery and frequent releases, just having that is often resetting the clock and essentially sidestepping workflows that commonly work on premise for tracking and ensuring that vulnerabilities are being followed up on and remediated.
Just before you go forward for a second,
Yeah.
I think this kind of like is almost the answer to the question that we posed earlier. So what happens to the risk, when the ephemeral asset goes away? And when you're trying to move from these point-in-time scans on ephemeral assets to a longer lasting or continuous risk management, what you really need to put in the middle is a risk anchor. What is something in my environment that is not changing, that is durable, that is longer lasting, and that is meaningful to the business, to the environment, so that we can group and manage risk around it. And this is the underlying, concept of adaptive contexts. It is identifying those anchors, and we'll give the example in the next slide, but then dynamically grouping all the relevant ephemeral assets as they move, as they change around that anchor, because that anchor is going to last for a while. So if you go to the next slide.
Yeah. All right. So when we think about traditional scanning for containers, often you might see there are container images that are usually assessed for their vulnerabilities. And historically, scanners will assess the container image. They'll see, all right, these are the vulnerabilities that are present on that container image. And we can deduplicate what version the image is based off of digest information, corresponding registry information, and image repo information. Where that kind of falls short is images are just part of the picture. You have also container runtimes, which can have deployment context, and also can have their own risk and misconfigurations. Oftentimes there are different versions for images that are out there, even for the same application, whether it's dev, test, production, but also can be shared across common applications. So the picture is quite complex. And so when we think about how to contextualize that, this is where we create this notion of container workloads, which is essentially a stateful and persistent asset that tracks the relationship across the different aspects of a container. So the orchestrated container images, the deployment or runtime of images that depend on or runtime of containers that depend on those images, and then the deduplicated list of vulnerabilities, misconfigurations, and compliance findings that are found across that entire landscape. So a container workload essentially serves as that unifying thread between the different ephemeral assets and providing a unified risk score as well as a unified picture when tracking the vulnerability lifecycle.
Aaron, before you go on, there's a question that came in. So the question is, if you have multiple environments, let's say you're running both on Google Cloud, Azure, AWS, some of the different environments, how would you understand or understand the assets across that?
Yeah, the container workloads, as we mentioned, this is a newer capability that we're just releasing. And actually, the initial support is through our first connector via Wiz. And so Wiz is actually providing us with a unified view across the runtime, the container images, the base images, in allowing us to stitch that picture together. But this is also something that we're building out across cloud native security tools. Defender, AWS, things like that. And really it's a function of pulling in the inventory of the different assets. So the deployments and runtimes, the container images, and then the unique identifiers for those container images, understanding base images that are associated with an image, the different versions identified through digests, and then being able to stitch that picture together. There are conventions that are out there that make that deduplication fairly standard. Where a lot of the security tools fall short is they're not drawing these relationships. Wiz has all of that data in one place. A lot of other scanning tools will actually require not just the scanners integrating, but also inventory integration with those native cloud providers. So it really does require having knowledge of the different layers of assets. But once we have that, the container workloads essentially makes those relationships between deployment, container images, base images, and the associated container workload.
Okay, and then there's a follow-up question. How you said that, I think you said you automate ownership. Can you explain that?
Yeah. Ownership is probably one of the more common challenges that we solve with our customers. And there's no one formula that works for ownership. There are differing levels of maturity for organizations. So some folks have an inventory versus don't have an inventory of ownership. Some folks have some level of trust versus a high level of trust in inventories if they do exist. Or there could be differing methods of ownership across different teams. There's no set standard, and so you have to be adaptable. So when we think about ownership, ultimately, first is understanding where you are within the maturity curve. Do you have a source of truth? Is it something that is maybe multiple sources of truth? Or ultimately, how is that identified? Within Nucleus, though, you have the ability to create dynamic rules through a no-code rule builder and essentially perform your assignment work automatically through your orchestration and automation tooling. So we can look at inventory data and route based off of that. We can integrate with scanners and pull in native metadata from scanners and use that for decision criteria. Or we can create customized rules where maybe it's based off of certain applications or repository names and creating rules where maybe there's no inventory that exists today. But ultimately, the goal of ownership is identifying what the best method is for routing and then creating an automated workflow so those routes are automatically defined and automatically executed. We could probably spend a whole other hour on routing and ownership.
Yeah.
But hopefully that gives a high level idea of kind of the thinking behind kind of narrowing down what is the best way of determining ownership.
Okay. And then one last question before we move on to the use cases. Are you also looking for misconfigurations of the cloud provider?
Yes. Yeah. So here we can see compliance style findings. These are typically misconfigurations, failed controls. These are commonly identified with things like a CSPM style scanner. That's one of the reasons why we introduced the 135 plus assets as we're seeing the evolution of cloud. Being able to understand what assets are being assessed, and they're kind of falling outside of the typical range of, are they network devices or hosts? Do these represent application style assets where it could be code or it could be application front ends, URLs or APIs? So these are introducing all new asset types where it could be object storage that is overly permissive, or default passwords on databases, right? Things that are being assessed through modern CSPM style scanners. So yes, these are also provided and layered into that view. All right.
Use cases, yes.
All right. So now let's cover a couple of use cases. So we've kind of understand what the container workloads are, what we're stitching together. Now let's cover a couple of different use cases for what that enables. So imagine that you have a sidecar that provides some useful utilities, maybe logging, storage, or what have you. And this is a shared service. So it's used across multiple applications, and there's different contexts depending on what applications are using this container. So if we have a container vulnerability and we want to understand, is this something that we should remediate today, or something that we should add to the next release, or something that we should work on more opportunistically? This type of context helps to understand where this falls in terms of urgency. So here we can see a critical internet-facing application that's handling sensitive data versus a supporting system that's not internet-facing, medium criticality, no sensitive data. Depending on the deployment context, there would be a different level of urgency that we might put in remediating vulnerabilities, where historically we've often looked at, is this something that is deployed? And that provides some level of visibility of the risk of a vulnerability on a container image, but even further, what's the business context for these deployed images? So now having all of this in one place, we can easily identify where our running containers are and what applications they're supporting, and ultimately what the risk is for remediating this container image. Another use case is when we think about the lineage of a container. So oftentimes we're in a continuous delivery process. We're frequently releasing updates. And so container images are frequently versioned. historically, that results in essentially erasing the state of a vulnerability. Oftentimes, after a certain period, container images are usually archived or removed from kind of active priority and workflow. So these vulnerabilities in this context entirely disappears often. Having a unified view across the lineage essentially helps you to identify when actually did a vulnerability first appear. So going back to that insurance company that was having trouble with setting SLAs, so they have an organization-wide policy for SLAs for critical, high, medium, low, and then varying levels of exploitability, and also business context, what's publicly facing or mission critical. How do they set SLAs? These SLA standards, though, are difficult, or they found to be difficult to enforce at the container level, because each new version essentially wiped the slate clean and reset the clock on SLAs. And so originally, all that they had the ability to do was to set an SLA based off of when the vulnerability was published or when a fix was published on that vulnerability or CVE. Now, this also was problematic because there are teams that would be out of SLA compliance the moment that they used a package or dependency that was vulnerable, because, say, that vulnerability, that CVE on that package was found to be vulnerable and had a fix published, for example, over a month ago, and they have a 30-day SLA for that vulnerability to be remediated. So they're immediately out of SLA compliance and immediately essentially dinged for their key KPIs or performance indicators that they track. And that led to degrading the relationship with the application teams, and really necessitated a better way of assigning SLAs. So now you can see where across all of the different and changing images, we can see the lineage of the vulnerabilities as well, anchoring the SLA based off of when something was first discovered, even if it persists through subsequent versions of that image. And I'm seeing some questions, but I know some of the questions I didn't see. So I see Bill Frank asked a question.
Yeah. So let me just read it for you. Yep.
Okay. Yeah.
If a cloud-only company deployed Wiz across all their application and cloud providers, is there still value add for Nucleus? So
Yeah.
I think there are actually two parts to this solution. You said, this is a theoretical. I think most of our target audience, or predominantly all, are enterprise customers. And that cloud only with only customer doesn't really exist in real life. So almost every enterprise that we work with has a diverse security stack that's just getting more diverse as as new M&As appear on the market and the company evolves. But there's still a very good question, very good answer for your question. So Aaron, go ahead.
Yeah, I think that's really good to point out, is that a lot of our customers do have disparate and varied environments. And so for those, there's absolutely, I think, a really easy connection to where they would derive value. But also these are capabilities that are entirely new across all scanners. So while Wiz provides a lot of the context for correlating the assets, the idea of managing the full life cycle across the lineage is not really something that they support end to end. And also it requires additional context with things like asset ownership, inventory, and also with things like vulnerability and threat intelligence to have kind of a full end-to-end approach. So there certainly are, I think, arguments for even really simple environments, Bill, like you highlighted. But then also as you start to add complexity and disparity between different systems and parts of the organization, say growing through acquisition, for example, then that even adds greater complexity and need for unifying this.
Thanks for your question.
Right. And Tally, just let me know if there's questions. I seem to only see a few questions when they come through, so I'll trust your eagle eyes.
There's just one more thing. When you talk Wiz, is it Wiz Cloud, Wiz Defend? It's both, and it is Orca, and it is a wide variety of other. You can go to our website. I'll actually drop it in on our integrations page. I'll just drop you the link in the chat, or Kevin, if you can for a second. We support over 160 different integrations, and a big chunk of those are around cloud providers, CSPMs, cloud workload protection platforms, as well as a host of applications, SaaS, DaaS, software composition, everything and anything. So yeah, thank you, Kevin. You can check it out and filter, but we actually do a very broad range of.
Yeah. Yeah, and specifically the container workloads, the initial release is with Wiz, but it's actually an overall data model. So it's adapted to really anything that scans containers and has container deployment services, essentially.
Bjorn,
all right.
I see that you just pointed out for the cloud for this use case, and I think that is the answer as well. We bring in all of the finding and asset data and unify it together. That is our first step. So as we ingest information from any source, we will deduplicate it, normalize it, and prioritize it. And this means that we are completely, our asset inventory is completely agnostic at that point to the source. We will abstract that information out. So it is true for any of our connectors. I hope that answered your question. Go ahead, Aaron.
All right. So one other use case. So when we think about the lineage of a vulnerability, we've talked a lot about different versions, but let's go back to the idea of base images or golden images. So oftentimes organizations might have a trusted base of base images or golden images that developers build off of. And so usually there's your base image, and maybe an application has some different dependencies, and so you make some changes to that image. And so the application itself is using a unique image, but it's built off of that base. And so if there are vulnerabilities that are common to the base, then it's really important to understand that. Otherwise, you're playing this whack-a-mole game of anytime there's an application team that uses this vulnerable base, you're going to see a new instance of that vulnerability and fix it at the kind of point of instantiation within the organization versus at the root. So being able to identify end to end, what's being deployed, obviously still providing that context, but tracing all the way back to the underlying base image and lineage of that vulnerability also allows you to understand who's responsible. There are other examples of a customer sending a vulnerability to the wrong team, where they look at fixing something and they see that, hey, this is part of a base image. And that's one of the ways that can erode trust. But also it can result in a team frequently seeing this vulnerability popping up and saying, hey, we just patched this. I'm not sure why, we're seeing it pop up again. Well, we're using the base base image, so it can pop up again or pop up across different instances. So reducing that rework and actually making teams more efficient at managing its risk. And actually, Tally, anything that you wanted to cover, I wanted to.
I think we're good with this one. Thank you.
All right. So actually, the enterprise strategy group did an analysis on some of these new capabilities and had a really, I think, interesting and insightful quote. Threat and exposure management in the cloud introduces an additional layer of complexity. Comprehensive contextual understanding in this environment is extremely challenging. Nucleus is addressing this issue directly with adaptive context technology. And I think, we can kind of understand all of the different elements of this, but it really is a challenge. And this is actually a novel solution from what we've seen of being able to easily trace things end to end. And Wiz, I think, is a great starting point because they have a lot of the information in one place. But as we're looking across the scanning landscape, there are tools that are scanning containers, but don't have all of that context to make associations. And so we're enriching outside of these scanning tools to be able to create this fully stitched together picture. So in summary, being able to manage risk with a continuous business aligned context and in cloud environments requires one, a unified visibility of your assets. And recall, an asset could be anything that's scanned, whether it's the base image, the application image or image versions, the running containers, or any of the surrounding infrastructure. Being able to understand what that inventory is and what the vulnerabilities are across that. Being able to then deduplicate findings and ultimately determine where is something happening within the different layers of a container, and then being able to orchestrate reliable ownership across a rapidly changing environment. All right. So Tally, I think I'll let you cover the next exciting webinar that we've got coming up. I think is the other Aaron, is he going to be on that one?
It's the other Aaron.
Yeah, there's two of us, so double trouble.
Yeah, so next month we will be talking about bridging ASPM and vulnerability management. So sort of like a shift left and shift right approach to scalable application security. And that one should be a very interesting one with one of our partners. And I think there is another question. It's kind of like long. Let me see if I can kind of like condense it. One is my question about Wiz only environment was just to clarify my understanding of our value add. Oh, so there's a comment. Thank you for clarifying. So yes, we actually really appreciate that question, because while one of our core values is that integration and unification, the automation, or what we call the making data operationalized, is without a doubt one of the things that our customers are most impacted by. Being able to really automate workflows very effectively, very efficiently across their enterprise, whether it's ownership, remediation, etc. So I do appreciate that comment. If I need to get vulnerability information from cloud native assets, what Wiz license should I get? Aaron, is that something that you're able to address, or we can take it offline and respond to you later?
Yeah, probably respond later. I unfortunately am not. I know how much I butcher Wiz nomenclature for their different license types and things like that. So I think it's probably best if we come back.
So apologies, we can take that offline and see if that's something that we can provide, or whether it's something that Wiz would need to. But appreciate the question, and thank you for the shout out for our integrations page, this is without a doubt one of our key focuses, and we keep implementing additional integrations as we move forward and have different requests from our customers. So thank you for that.
All right, and then one other slide. So make sure that you get this QR code as well. But also, if you are interested in a demo, please do scan the QR code. We do offer demo on demand.
Aaron, does this lead directly to your mailbox or not?
It doesn't lead to my mailbox, to my knowledge, unless Tally, you've redirected it.
I've hacked the QR code. Not this time.
It's not April Fool's anymore though, so no more pranks. But be sure to request a demo if you are interested in learning more. In any case, about anything within the Nucleus platform. Certainly look forward to hearing from you all. And with that, thank you everybody for the participation. Hopefully we'll see you on the next one as well. And yeah, have a good rest of your day.
Thank you, everyone.